Good day, Bayouts! Welcome to our channel, Bayout Tutorials. In this video, we are going to solve a problem in Chapter 8, Open Channel, from Fluid Mechanics and Hydraulics, revised 1st edition by Jack D. Yvette and Chin Lee. So, the two types of conduit are used to convey water, the open channel and the pressure conduit pipe, which was discussed in Chapter 7. An open channel is one in which the stream is not completely enclosed by solid boundaries and therefore has a free surface subjected only to atmospheric pressure. The flow in such a channel is caused not by some external head, but rather by the gravity component along the slope of the channel. In an open channel flow, the hydraulic braid line is coincident with the stream surface, since the pressure at the surface is atmospheric. So the flow in open channels may either be uniform or non-uniform. So let's proceed to our sample problem. So a rectangular channel with a width of 3.0 meter and an end value of 0.014 is to carry water at a flow rate of 13.4 meter cube per second. Determine the critical depth, velocity, and channel slope. So before we are going to solve what is asked in this problem, we need to identify first the given values. So we have the value of width, which is equals to 3.0 meter, the end value, which is equals to 0.014, the value of our Q, which is equals to 13.4 cubic meter per second. Now we identified all the given values, we can now proceed to our solving. So for the critical depth, we can use this formula. D sub C is equals to Q divided by W squared divided by G times 1/3. So, and plugging all the given values, we have 13.4 divided by 3.0 squared over 9.81 1/3. So simplifying this equation, we get the value of DC, which is equals to 1.267 meter. Now we have the value for the critical depth. Next, we need to find the value of velocity. Velocity is equals to Q over area. So 13.4 divided by 1.267 times 30, it is equals to V sub C is equals to 3.525 meter per second. So now we have the value for our velocity. And last, we need to find the value for our channel slope. So, but before that, we will going to find the value for our hydraulic radius, which is equals to area over P sub W. So R is equals to 1.267 times 3.0 over 1.267 plus 3.0 plus 3.0. And simplifying this equation, we have the value of R, which is equals to 0.6868 meters. Now, we already have the value for R, we can now solve for the channel slope. So, the formula of channel slope is equals to N times VC divided by 1.0 times R raised to the power of 2/3 squared. So, by plugging in all the given values, we have 0.014 times 3.525 over 1.0 times R, which is the value of 0.6868 meters squared. And by simplifying this equation, we got the value of the channel slope, which is equals to 0.00402. And now, we already determined the value of critical depth, which is equals to 1.267 meter, the value of velocity, which is equals to 3.525 meter per second, and the value of channel slope, which is equals to 0.00402. So that's it. I hope you learned something from this video. Thank you.